Chapter 5, Linear Functions, Section 1, Rate of Change and Slope. We've talked about finding the constant rate of change in a linear function already. We call it the slope, and we represent it using the variable m. The rate of change is the change in the dependent variable, which we know the dependent variable is y, over the change in the independent variable, which we know is x. Now, we've also seen this as m equals y2 minus y1 over x2 minus x1. Some of you have even seen it as delta y over delta x, where that little triangle just means the change in y over the change in x. So if we look at the table on the left, we see that the x variables are increasing by 1 each time. You're adding 1 each time, so there's a common difference of 1 on the x variables. Now the y variables from 260 to 520, we can see that we're adding 260. From 520 to 780, again, we're adding 260. 780 to 1040, if you need to check in your calculator, find the difference between them. The difference between them would be 260. You're adding 260. And same thing, 1040 to 1300, you're adding 260. So we can see that the change in y is 260, positive, and the change in x is 1. The other way that we can do this is to pick two sets of coordinates. So let's say the first two sets of coordinates, and let this be our x1, y1, and let this be our x2, y2. Well, we would do y2 minus y1 over x2 minus x1. We'd get the same thing, which means that our slope, m, equals 260. And we know that this is linear because both the x and the y values have a common difference. That's the rule for linear. If the x and the y have a common difference, a constant rate of change, then it's a linear function. Finding slope using a graph is a little bit different. You may have heard of rise over run before. So if you start at one point, let's say 0, -2, you want to see how many you rise up and how many you run over to get to the next point on the graph. So we rise up +1 and over +2. When you go up, it's positive. When you go right, it's positive. When you go left, it's negative. And when you go down, it's negative. So we went up +1 and we went right +2. So we could say the slope of this line is 1 over 2. Now it works the same way in the other direction. If you start at this point and you go to this point, you're going down, so -1, and left, so -2. Well, isn't it true that negative divided by a negative just leaves you with a positive? So either way, you still get the same point. This is also an alternate way to graph. You can plot the y-intercept, and then using the slope, you can go up 1 over 2 or down 1 left 2. Now, in order to plot both sides, so in order to go towards the right and towards the left, you'd have to use both of these, negative over negative and positive over positive. If you had a slope of something, let's say that the slope was -3 over 4, on your coordinate plane, let's say your y-intercept was 2, you would go down 3 over 4 and plot your point there. So you would go -3 but +4 because only one of them can be negative. Now this is the same thing as saying +3 over -4. That would be graphed as up +3 and left -4. So changing where the negative sign is gives you both sides of the graph that you're graphing. So when the slope starts off as negative, one is negative and one is positive, and then you switch them. When the graph starts out as positive, you can also write it as negative, and when the graph starts out as negative, that's the example we saw here before. You can write it as -1 over +3 or +1 over -3. They all mean the same thing. So here we have the slope formula again. You notice that you can write it as rise over run or as y2 minus y1 over x2 minus x1. But notice it says where x2 minus x1 does not equal 0. Because if the numerator is 3, let's say, and the denominator is 0, that would be a slope that's undefined. And we know that the type of line that has an undefined slope is a vertical line. So that's why it's clarifying that the change in x, cannot equal 0. So try this example. Find the slope using the following points. The line that goes through -1, 0, and 3, -2. Well, let's say this is our x1, y1, and this is our x2, y2. We'd plug in y2 minus y1 over x2 minus, and I'm going to write it in parentheses to separate the negative signs, are -1. Well, -2 minus 0 is -2. 3 minus -1, you keep the sign of the first, change it to addition, change it to a positive. So you get 3 plus 1, which is 4, and then always reduce it. So this reduces down to -1/2, and that's what our slope is equal to. M equals -1/2. Now you can write this as the negative in front, the negative in the denominator, or like the first way I had it, the negative in the numerator. Again, something we talked about in class, finding slopes of horizontal and vertical lines. Well, we know that the example on the left is a function because it passes the vertical line test, whereas the example on the right is not a function because it fails the vertical line test at infinite points. Well, HOI stands for horizontal lines have a 0 slope, and you would write them as y equals. So the equation of this line would be y equals whatever the y value is for all of these points. So 2, 2, 2, y would equal 2. The same thing goes for vertical lines, which we know have an undefined slope, and they're written as x equals whatever the x value is for all of them. So all of them have a -2, so that would be the equation. Now the slope here we said is 0, the slope here we said is undefined. You can see that even when we plug it into the slope formula, and I use these 2 points as my x2, y2, x1, y1, 2 minus 2 over -2 minus -4, we get 0 over 2, so the slope is 0, so it even works in the formula. Whereas here, if this is my x2, y2, and x1, y1, we get 3 minus 4 over -2 minus -2. So keep, change, change. You get 0 in the denominator, so the slope would be undefined. Again, we have a little bit of review here. You can just draw a sketch of these lines. We can see that a positive slope is increasing. So literally the slope here, we're going up 1 and over 1. The slope would be a +1. Whereas here, we're going rise over run would be down 1 and over 1. So the slope would be -1 over +1, which is -1. Here our slope is 0 because it's a horizontal line, and here our slope is undefined because it's a vertical line, and we know that this cannot be a function because it fails the vertical line test everywhere. Finally, for those of you who remember Mr. Slope Guy, we have our face. When the slope is positive, the line is increasing. When the slope is negative, the line is decreasing. When it's a vertical line, the slope is undefined. And when it's a horizontal line, the slope is 0. So easy way to sketch it on a test and remember what each one is supposed to look like.